Okay, so good evening once more. Today we'll be looking at LLMs, prompts, and chains. Last week we already looked at, we already introduced Agentic AI, and we tried to set up our systems for the practicum in the course. So gradually we are jumping into the meat of it. So we'll look at LLMs, prompts, and chains this week, starting today. Firstly, I would like us to recap what we talked about last week because we are building on that. We talked about AI and agentic AI. Who can help us say what AI is and what agentic AI is in your own words? Who would like to help us?
Can I go, sir?
Yes, please go ahead.
Okay. To me, AI are just systems that help us automate tasks that require some level of intelligence, whilst agentic AI is just we using those systems to sort of automate, sort of give them autonomous control over certain tasks or action. So basically,
Who else would like to say something what AI is and what agentic AI is?
Oh, my hand has been up.
Go ahead, please.
Hello,
Go ahead,
everyone.
please.
Okay. So, as we all know, as I know, artificial intelligence, is a type of intelligence or technology that aims at mimicking human intelligence. And beyond artificial intelligence, we have agentic AI. So, based on my understanding, artificial intelligence um has different subsectors. So, we can have something like basic human intelligence, just the way some humans are like more intelligent than the other. So that's something that agentic AI gives us. It gives us like a more intelligent system. And what is particular about agentic AI is that it gives us the ability to build autonomous systems, systems that um you give an intent, it has a goal, it can execute, it can reevaluate whether it did something bad or good, then it can improve on itself and give a better result. Thank you.
Sorry, I didn't know I was muted. I was saying that please, if you're not speaking, mute yourself. Also, rename your profile here. I'm seeing an iPhone. I was seeing a Zoom user. Those are clearly not human names. Please rename yourself. That way, if you're speaking, we know who is speaking. If you raise your hand and I want to ask you to go ahead to speak, I'll know what name to say. But I definitely will not say iPhone. I definitely will not say Zoom user. Okay, I think Zoom user has renamed themselves. Okay. All right. Thank you very much. That was a good one. So let's move to agentic AI architecture. Who can help with that? Anyone? Okay, Boluwatife, please go ahead.
Okay, so the agentic AI architecture is divided into about, I think, 4 or 5. We have the goal or the intent layer, and that layer is just to understand the particular task and objective. Then after understanding the task and objective, the next thing is to, or the next process is to reason and plan. Then after that, after reasoning and planning, that is after creating an action plan, then the next step is to execute the action. The execution of the action might require interaction with external systems. Then external systems, an example is like maybe a database, maybe a CSV file, an Excel file, or probably an API. And it could also be like an IoT system, a sensor. Yeah. So it will execute that action. Then after that, the next process is the memory layer, the feedback. And then I think another layer again that I forgot.
Okay, who can help with the layer that he has forgotten?
Environmental interaction layer.
Yeah, that's correct. That's correct. And Boluwatife, those are actually layers, not processes. Processes is like this happens, that happens. Those are layers. So there can be different processes within those layers. Okay, but you got it correctly anyway. The next is agentic AI workflows. Who can help with that one? Okay, while we are waiting for someone who would like to help, I would just like to mention that it's in the workflow that we now talk about processes. So the processes that happen and each of those processes map to one or the other of the layers, right? So what are the systematic steps that an AI agent takes, the processes that it follows to achieve the task that is given. That is the workflow. Yeah, Nancy May, you may go ahead.
Oh, so sorry. Good evening. I was just trying to get used to my system. It was an error for my part. I'm so sorry.
Okay, that's fine. So that's essentially what the workflow is, just the structured processes that the agent follows to achieve its task. And now applications of agentic AI, we talked about the areas of application. Nonsi Shiaki, you want to say something? Go ahead, please. Did I pronounce it correctly? Your name?
That's good enough, sir. Agentic AI workflows. We have the intent analysis, the plan generation, then we have the action. So after it takes the action, it observes. So if there's need to adjust the plan, it adjusts the plan. But if there's no need to adjust the plan, it will go to the task, like to complete the task. Yes, so it's like matches with the layers that he spoke about earlier.
Okay. I think I should add here too that it's also very possible. I know we talked about having that feedback loop where you move between action, observation, plan adjustment until you have successfully achieved the task where you here refers to the agent. It's possible for an agent to be built such that from actions, it just goes to task completion, in which case there's no such loop, such correction feedback loop. It's possible. Just that what we provided in the class was just an example of a workflow. But definitely every agent would have analyzed intent. Yeah, it should generate a plan because I mean it has to be a plan to take an action. Because if it just intends to action, well, there must be a plan, whether internal or it comes up anyway. Okay, so we now move to what we have for the day. Adobe, you want to say something? Go ahead, please.
Yes, good evening to you.
Good evening.
So I'd like to ask, what will be the major difference between AI and agentic AI with common examples? This question is just to get enough clarity between the two.
Agentic AI is a form of AI. It's just that it has that agentic capacity. Agentic implies that it has some autonomy, can carry out actions with minimal human supervision, minimal human intervention. That's what makes it agentic. That's basically the difference. Agentic AI is still AI. It's just that it has the capacity of agency.
All right, so we can say they can carry out end-to-end task operation with minimal supervision.
Well, end to end is relative, but it's just that it can carry out its tasks with minimal human supervision. Essentially, it can plan, take actions, it can make decisions, it can adapt, and it can correct itself. And it's essentially that agency, that autonomy that makes it agentic. Was that
All right.
okay?
Thank you.
Okay.
Yes, yes, it does.
So we move to what we have today. We'll start with LLMs. LLM is simply an acronym for large language model. There are language models that are not really large, but well, we work with some not so large models in this course, primarily because that's typically what we'll be able to run locally. I mentioned that we'll be working with Olama, so we can use locally run models as much as possible. But where we need more powerful models, we use a Grok API. Okay. So a large language model is just a neural network that is trained on a large amount of text data. It's trained to predict the next token. For now, just replace token with word. We are going to see what token actually is later. So essentially, what it does is to predict what the next word will be. Given a sequence of words, it predicts the next word. And after the next word, it can predict another word and so on. So it ends up predicting a sequence of words, one after the other. That's a simple description of a large language model. An LLM, it learns the patterns of a language, the patterns in the logic of a language. Of course, it gets word knowledge because the text that is trained on contains word knowledge. So it learns statistical patterns of language, of logic, and of word knowledge. And that's how they are able to become so smart, in quote. LLMs are commonly built on transformer architectures. Yeah, there are a few that are built on different architectures from transformers, but primarily they are built on transformer architectures, and they rely on self-attention to process sequences of tokens efficiently. Self-attention is really okay. When we finish talking about tokens, I'll explain what self-attention is. Now I will need to ask, who could you give examples of LLMs? Just type in the chat. Examples of LLMs. OpenAI is not an LLM. OpenAI is a company that has developed some LLMs. Yeah, it's one of the leading AI companies in the world. GPT, yes, GPT is actually like an architecture, right? There are these actual LLMs like GPT-2, GPT-3, GPT-4, GPT-03, 01, and so on. ChatGPT is not an LLM. ChatGPT is an AI product, a chat AI product that is built around LLMs. So ChatGPT itself is not an LLM. Yeah, Llama, Llama this, Llama that, Llama 2, Llama 3, Llama 4, and so on. Grok, yeah, someone say GPT-3 is here. Ollama is not an LLM. Ollama is, I would say, a platform that allows you to run LLMs locally. Now, I think they have added a cloud offering, so you can run larger models in the cloud from Ollama. Well, you could access. I would say that since you're not running them, and so on and so on and so on. So we need to yeah, I see quite examples here. So we need to distinguish between the model itself and the products that the model powers. They are actually different. DeepSeek itself is not a model. DeepSeek has specific models, right? But I think I've distinguished that using ChatGPT and the GPT models. Now let's move ahead. What is a token? Excuse me. I mentioned earlier that an LLM is trained to predict the next token, right? Given a sequence of tokens, it's able to predict the next token. So a token is essentially the basic unit of text that an LLM processes. Remember, they are called large language models. They are text-based, right? Yes, we have multimodal models now that can understand text, image, sound, and so on. But at their core, I mean, large language model is essentially text-based. So, sorry, excuse me. A token is the basic unit of text that an LLM processes. So it can be a word, it can be a single character, it can be punctuation, like full stop, it can be part of a word. If you see here, there's this sentence I have here, they surreptitiously created that impression, right? I used the OpenAI tokenizer to tokenize this I don't remember which of their tokenizers, but I know it was OpenAI tokenizer that I used. And so it has divided that sentence into tokens. The first token there is they. The second token is the space plus SUR. The third token is the RE. The fourth token is PT, and so on. So you see, they as a full word is one token. The space with the SUR, that means the space plus part of a word becomes one token. RE is one token, part of a word. If you continue, you see that space plus created is one token. Same thing with space and that. If you continue, you see that the comma is one token and the question mark is a token. So essentially, a token is a way of, is that unit of text that the LLM processes. When you give it the LLM a sequence of text, it chops it up into tokens, and those tokens are what it processes. They are actually not represented internally by letters, right? They are represented by their vectors. So they're actually represented by numbers. Okay, but I mean, it chops it up into these bits and they are represented internally by numbers, and it's those numbers that the LLM processes. Any questions so far? Yeah,
Please, can I
please
see
go
the
ahead.
first slide just briefly?
Which slide?
The first one, sorry.
The first one is where we have the
Just,
title of
just
today's.
before this one.
Okay.
Just before this one.
No problem. This one? Is it this one?
Yes, please. Thank you. You can go
Right.
on.
Somebody was trying to speak and I said, go ahead. I don't remember who anymore. Somebody had raised their hand and I said, go ahead.
Sir, please, listen to me. Can you hear me? Am I audible?
Yes, you're audible, but it's breaking up.
Can you hear me?
Yes, I can hear you.
Please, can you hear me?
Yes, I can hear you.
Oh, man.
Okay.
Can you hear me?
I can hear you clearly, but if you can't, perhaps it may be better to drop your question in the chat, but I know I can hear you. You seem not to be able to hear me. Okay, let's continue then. How do LLMs work? I'm still audible, right?
Yes, sir.
Okay. How do LLMs work? A lot of people think that LLMs are magic.
Okay.
As an actual magic, right? But they are not. LLMs, they don't understand language like humans. When you communicate as a human, right? Sometimes it's not just what you say, context matters. I'm trying to think of an example. There was a few years ago in Nigeria, it was I pray. I pray had nothing to do with prayer, right? So humans understand not just what is said, the context, there's a nuance. Well, in speech, even the tone. Today, when they say this guy is a mad rapper, do they mean that he's insane? Even the word insane, that's insane. it depends on the context. It could mean something different. LLMs may not really understand that finely nuanced. Their understanding may not be as finely nuanced as that of humans. They just model the language patterns that they learn from their training data. So it really depends on the training data. They just model those patterns. So when they are being trained, each layer, I mentioned earlier that they are built using transformers, right? So they have layers of transformers. So each layer learns the relationships between words via self-attention. Remember earlier I said I was going to talk about attention. Now, self-attention is about not just learning the words, but learning each word relates to the other words in a sequence. For example, I'm trying to think of a word. Okay, the cat must be hungry. It should go and sleep. The cat must be hungry. It should go and eat, not sleep. The cat must be hungry. It should go and eat. Now, when they say the eat that should go and eat, what does it refer to? No, that's not a good. Okay. Okay. The cat is on the mat. It probably wants to sleep. The cat is on the mat. It probably wants to sleep. What probably wants to sleep? Is it the mat or the cat? What does it there represent to that probably wants to sleep? Is it the cat or the mat? Okay, I'm saying some text. The cat, yeah. So self-attention is about learning how each word relates to the others. It's through self-attention that the LLM will be able to learn that it there refers to the cat, because the self-attention between the cat and that it is not the same as between the mat and that it, right? So self-attention is the mechanism that allows it to learn the relationships of interrelationship of different words in a sequence of text. And so it's able to learn the logic of the language. And that's essentially how it's training it is about providing data to it in such a way that it learns such relationship. So the objective of training the LLM is just to minimize the error of predicting the next token. Remember, we mentioned that LLM is trained to predict the next token, right? So it can predict the next token correctly or wrongly. That training is just to minimize that error of predicting the wrong token, so that majority of the time it predicts the next token correctly. And the output is essentially just a distribution over possible next tokens. So there could be many possible next tokens, but usually the output you get is the one with the highest probability. It really depends on the settings, but typically you get the one with the highest probability. So essentially you have an input text sequence, it gets tokenized, and that sequence of tokens gets processed in the layers of the transformer, and the next token or next token sequence is predicted, and that sequence is detokenized. Now, when it is tokenized, the text is converted to the vectors I mentioned, chopped up into tokens, and those are converted into vectors. And when the next token is predicted, it's actually a vector that the LLM outputs. So that vector is converted back to human readable text, and that's the process of the tokenization. And that the tokenized sequence is now output as text. That's essentially how the process of an LLM functioning. Any questions so far? Okay, so we'll proceed. So what are the capabilities and limitations of LLMs? LLMs can generate text. That's the primary thing they do, generate text. So they can generate text creatively, even though there's this argument of whether it's really creative, given that it's essentially trying to generate patterns it learned from the text that were fed to it during its training. Okay. They can summarize text. So you can give it some text and ask it to summarize it, maybe in 2 words, in 2 sentences, whatever. You can summarize that text. It can translate text from one language to another. It can, even beyond that, it can take this one text and reproduce that text in a different writing style. That's the form of translation anyway. It can reason about a given context. And because it can reason, it can debug code. Because it can reason and it can generate text, it can generate code from scratch, and it can also refactor code. And it can simulate experts. A lot of people who use ChatGPT use it as this is actually the capability that they make use of. Asking questions and it answers. So you can simulate an expert. But what are their limitations? Those include LLMs can hallucinate facts. They can tell you something that's actually hallucination, tell you as a fact, but it's nowhere near a fact. So if you do not know this, you can swallow what they say hook, line, and sinker. LLMs are sensitive to the phrasing of the text that the input text that you feed to them. So am I audible? Can you hear me?
Yes.
Okay. I lost power a bit, so I was waiting for my internet connection to switch to another one. Okay. So what was the last thing you heard so I'll know where to continue from?
The hallucination fact.
Okay, so they can
Yeah.
hallucinate. So if you're not aware of this, you could swallow what they tell you, Glenn and Sinker. Okay. The next thing I was talking about after the hallucination was that they are sensitive to the phrasing of the input text. So if just changing one word in your input text can change the response that the LLM will give you. They're sensitive to input text phrasing. They have no intrinsic memory. They don't remember anything. So for them to remember, you have to provide them with a memory tool, which is one of the things we use in building agents, provide them with memory. And they have no real world grounding. So those are some of the limitations of LLMs. And it is important we understand these for us to be able to make use of LLMs as we build applications that are powered by LLMs. We need to understand their limitations. We need to understand their capabilities. So at this point, I would like to ask us which categories of tasks based on these capabilities and these limitations that I talked about, what categories of tasks do we think are safe or that are risky to trust LLMs with? If you'd like to say something, please Yeah, trust. Go ahead.
So I think it's very risky to trust LLMs with simulating experts. So, for example, because LLMs run the risk of hallucinating, if somebody is not careful or is not like vast in the field and is asking in a particular field and is asking a question, he may not be able to identify when the LLM is hallucinating, and he may just believe the information. And if we have interacted with them, especially ChatGPT, we'll see that sometimes they are very confident in their answers, and it will be like if it's very correct. In fact, you will not think that it is wrong. So imagine somebody that is facing an health crisis who needs the expertise of an LLM or an agent that can do that or that can give health advice. Is now giving a false output that can be disastrous and unsafe for that person.
Yeah, that's one of the things. Some people use ChatGPT as if it's a psychologist, and that's not so nice. Adobe, you want to say something? Go ahead, please.
I think it will be safe to use it for brainstorming, like some ideas, writing articles and all that. I think it's safe doing that because mistakes can easily be spotted and corrected by humans. So I would say that is the safe part of it. And also for research, it can be used as a research assistant because it can be given supervision, which can be easy as long as the key facts are verified. Yeah, thank you.
Okay, when you talk about using LLMs to write articles, have you thought about the issue of plagiarism? Have you thought about the issue of intellectual property infringement? Is there no risk of that when using LLMs to write articles?
Yes, there may be, but generally, I think, let me say from experience, it draws facts from so many sources and try to put them together to generate something. So I think I know that someone cannot just use exactly what it does from any of the LLMs and all that. You can still work on it. So it's mainly to generate idea and then put it in a proper way. So yeah, for the sake of plagiarism and all that, it can't just be used and it can't just be depended on. That is why I said as long as facts are verified.
Okay, that's good. Yeah, Joshua, I had mentioned earlier that ChatGPT is powered by LLMs. Do you have a ChatGPT account? If you do, you see that you're able to, depending on the tier of your account, you may be able to select which model you're interacting with. So ChatGPT is powered by LLMs. It's just an interface that allows you to chat with an LLM. Does anyone else want to talk about the category of tasks that is safe or risky to trust LLMs with? Okay, Olanre, what your hands are raised, please. Your hand is raised, please go ahead.
Yes, sir. Please, mine is a question, sir.
Okay, go ahead with your question.
On the last phrase, no real world grounding. Is it about knowledge, sir?
No real world grounding. Inherently, LLMs don't understand how the world works, right? They don't understand how the world works. So it's training that tries to help give them some knowledge of the world, but still, they are still limited. So a human understands how the real world works. LLMs they just learn patterns from the text on which they are trained. Yes, they may some of the things they learn might relate to the real world, but they are not grounded in how the world works. For example, unless a child is born today, if that child touches something that is hot, even though if a child that was born today gets to touch something that is hot, then the adults around have issues. If that child touches something that is hot, that child knows that it is dangerous and that child reacts accordingly. An LLM has no body. It has no body. It's just, let me say, software that is running somewhere. So it has no real world grounding. It's not grounded in the real world. Some people will talk with ChatGPT as their friend and everything. But who is ChatGPT? Some people will be discussing with Meta AI as their friend, but who is Meta AI? Yes, Adobe wants to say something.
Yes, we talked about examples of LLMs. I think I missed that part. What are the examples that you told us?
I didn't tell you any examples. Any example? A number of you mentioned examples, right? I just tried
Yes.
to explain that, like somebody mentioned OpenAI. I tried to explain that OpenAI is not an LLM. It's a company that builds LLM among other things. It's an AI company. Somebody mentioned ChatGPT. I said no, ChatGPT is not an LLM, but it's a product built around an LLM, right? But some people mentioned somebody said the GPT series or something like that. Yeah, and I also mentioned GPT-2, GPT-3, 3.5, 4, 4, 4.0, 0.3, and 0.1, and so on. Somebody mentioned DeepSeek, and they said, no, DeepSeek on its own is not an LLM, but they have LLMs, right? Somebody mentioned Llama, and I say, yes, Llama 2, Llama 3, this 3.2, 3.5, Llama 4, and so on. Those are the LLMs. It's something that a Google search can easily, information that a Google search can easily provide, right? The LLM is the language model itself. It's not the company that makes the language model. It's not the product that is powered by the language model. Do we move on?
Yes, please. Thank you.
Okay, you're welcome. So now, where do LLMs come in agentic AI? Essentially, when we're talking about the agentic AI architecture, one of the layers was the reasoning and planning layer, right? That is where the LLM comes in. The LLM functions as the reasoning and planning core of the agentic AI. So it works with memory to store context and history. Remember, we had mentioned that LLMs do not have memory inherently, right? So you need, if when building an agent, if you want to store context and history, you need to provide memory to the LLM. LLMs, they work with tools to be able to execute real-world actions, and they work with feedback to be able to self-improve, to improve their own performance. So the LLM forms the reasoning core. They form the, if I may say, intelligent core of the AI agents. Are we clear on this? Does anyone have any questions so far? Okay, no questions, so we continue. Now, LLMs have a number of parameters, but I'll just outline a couple of them here. One is temperature. So the temperature it controls the degree of randomness of the LLM's output, how creative it is, so that for a given prompt, does the LLM give you the same output each time you give it that same prompt without any other thing changed? That is controlled by the temperature. So by adjusting the temperature setting of the LLM, you can control how random its output is. The other parameter is the top P, which limits to the most, it sets limits to the most probable tokens. What does it output? Essentially, by your setting of the top P parameter, you try to control whether how far below. I'm trying to find a way to explain this. Okay, if you remember, I mentioned that the output is a probability distribution of tokens, right? Now, I mentioned too that the output is usually the one with the highest probability. The top P setting controls that. Depending on your top P setting, you might not get the predicted token with that has the highest probability, or you might get it. It depends on the top P setting. Another parameter is the max tokens, and this controls the output length of the LLM. So its outputs cannot go beyond the max tokens that was set. It can be less, but it can be more. So the larger the max tokens that was set, the more verbose the LLM would tend to be. Next one is context window. The context window relates to how far back, how much history, how much context, how much history, how much information the LLM can remember. The larger the context window, the more of your conversation history the LLM can remember. And typically, the better your experience interacting with the LLM. Please give me 1 minute. Okay, thank you. Any questions so far? None. right? So
Yes,
we
sir.
move
I
ahead.
have a question,
Okay.
sir.
All right, go ahead, please.
Yes, sir. I don't know if you might to work with the last slide. When you asked if there was a question, I found it difficult to raise my hand. I couldn't find the button.
Last slide, that's in this one.
No, the previous one before this.
This
Before
one.
this. Sir, before this one, sir. Yes, sir. There was a statement you made around the. No, sir. Next, sir.
Next.
No, I mean not this one. Next, as in forward, sir, not backwards.
How LLMs work?
Yes, sir.
Okay. Go ahead with your question then.
Oh. No, sir. I mean you went 2 steps backwards, sir. I mean just the step behind it. Actually, my question was I wanted to link it with the agentic workflow, where you
Which slide
listed
are you referring to so that I can go to that slide?
Is that the very previous or 2 steps
What
behind
was
the
the
current
slide
one
talking about?
about reasoning and how LLMs how
LLMs in
LLMs
agentic AI?
like the brain. Yes, sir. Yes, sir.
Okay.
Being
Go
like the
ahead, please.
brain of the. Okay, so my question was I was trying to ask. Okay, yes, this is it, sir. Thank you, sir. I was trying to ask if this has to do with the in the general flow. You know, you told those actions, go to observation, then you can plan, readjust the plan, then go back to action, then observe. Is this what the LM does in that respect, sir? Because I can see this like a circle there to acting, reflecting, you know.
That's is just illustrating that that graphic there is just illustrating that for this to happen, for there to be reflection or remembering through acting, there's reasoning at the center. And that reasoning core is the LLM. That's just what that is illustrating.
Okay, sir. So my
Just
question was that.
illustrating that LLM is the reasoning core of
Okay.
an agent. That's all.
Okay, sir. Thank you, sir.
Adobe, you raised your hand.
Yes, the last slide, just before he started asking questions. The top
This one?
P is here. Yes, here. The top P is not quite clear. I didn't really understand that. Can you help explain again? Thank you.
Okay. Earlier, I think a few slides before this, I mentioned that the LLM essentially predicts the next token, right? I mentioned that the output is a probability distribution of, I'm trying to get to that slide. Yeah, it's a probability distribution over possible next tokens. If I remember right, I mentioned that there may be different possible next tokens. So it assigns a probability to each of these possible next tokens. If the probability is 0, it means that that thing can never be the next token. If the probability is 1, it means that that is definitely the next token, but it's rarely 0 and 1. It's rarely black and white. It's more like different shades of gray. So the top P means, okay, let's assume that it has this bucket of possible next tokens, right? And it assigns probabilities to each of these possible next tokens. And now let's assume that the higher the probability, the more that the possible next tokens with high probability float to the top of that bucket, while the ones with low probability are at the bottom. Let's just assume that that's how it happens. Now, the next token that will be output to you will be picked from the top, right? Now, your top P setting determines whether it picks from the top or whether it's how deep into the bucket it goes to fetch the set of possible next tokens that it can select from. I don't know whether that analogy makes this clear.
A bit. Well, you said top P. Some of them, the ones that are down there, are not likely the most probable ones. And then your last statement said how deep it can go to get the next possible token. It's now confused me the more again. That last statement.
I was
I don't
using
know if you can throw more light.
an analogy of a bucket containing
Yeah, I
all
understand.
tokens, right? Now, I was saying that
Okay.
let's assume that a token with a high probability will be at the top of the bucket. A token with a very high probability will be at the top of the
Yes.
bucket, while a token with a very low probability will be at the
Okay.
very bottom of the bucket. Now,
Mm.
it needs to select some tokens from this bucket. It needs to select some tokens from this bucket and put them into a plate. Right, out of all these plenty tokens, it selects some, put them in a plate, and it's from those tokens in that plate that one will be picked and given to you as the output from the LLM. Now, the top P parameter controls how large this plate that he puts those tokens, the selection in. Assuming it has to fill that plate before it presents to pick one to give to you. The top P parameter controls how large that plate will be. So if it's a small plate, it's only a small subset. That means it's really the top probability ones. If it's a large plate, it means it will even select, it may even select ones that where the probability is not so high. Does that make it clearer?
Yes.
It
I'll still research on that.
Just controls the subset of probable tokens that can be output. That's what it controls, the subset of probable tokens that can be output to the user for the given input sequence.
Okay. Okay. So, one more question. Why is it called top P? What does that P mean?
Top P, probability. Top.
Oh, okay. Thank you.
All right.
Thank you.
All right.
That would be all.
Okay. So we move to prompts. We've talked about LLMs, and now we move to prompts. Now we understand how where LLMs are situated in the agentic AI architecture, right? Now the question, and we've been talking about, you provide an LLM with a sequence of tokens, and it processes that sequence of tokens and predicts the next token, right? How do you talk to this LLM? How do you provide it with that sequence of tokens? And that is where prompts come in. So a prompt is just like, is the structured text that is given as input to the LLM. And it serves to guide the LLM's reasoning of which, of course, is output. So it's the structured input that is provided to the LLM. Of course, it's a text. I had mentioned that LLMs are text-based. That's what a prompt is, the structured text that you impute into an LLM to guide its reasoning. And of course, its output. So a prompt, for good prompts, should be clear. They should have clear objectives and scope. What is the objective of the prompt? Remember, we talked about intent when we're talking about agentic AI architecture. So a good prompt should clearly specify the intent and then the scope. So it shouldn't be open-ended. It should provide a clear scope to that intent. It should provide sufficient data, sufficient context to enable the LLM to achieve the intent. If you don't give it adequate context, adequate data, it cannot provide a good output. You may not be able to achieve the intent. A good prompt should outline a structured request. The request in the prompt should be structured, perhaps by outlining the steps to be followed, perhaps by listing the context, providing context as a list, perhaps by including examples. But you should outline a structured request. There should be some structure in that prompt. And it should also should specify the output format. In what format do you want the output? A good prompt should specify that. If you do not specify the output, LLM is free to provide the output in whatever format it wants. But usually, an LLM functions better. It's better able to serve you when you are clear about your objective and you provide a clear scope, you give it adequate context, your request is structured, and you specify the format of your output. Just a moment, I need to get a drink of water. All right, thank you. I'm back. Any questions so far about prompts and the desired characteristics of a good prompt? Okay, none. So we move ahead. Okay, there we go ahead.
Yeah, this one is just like maybe a general question or just on a lighter note. Why does it feel like LLMs provide better answers when they receive prompts, maybe the same prompts more than once? I'm talking from personal experience.
I'm trying to understand, as in you give it one prompt, it gives an answer, you give it that same prompt, the next time you get a better answer. Is that what you mean?
Yes, it tends to work more on the second one and the third one. It must not be the exact prompts. It can differ, but yes, it tends to provide better prompts when you do it like the second time and the third time. I don't know, but I'm talking from my own personal experience.
Okay, just to disambiguate, you give it a prompt, it gives you an answer, and that
So they
answer
used to
does not really.
say, if you are give
Go
you what
ahead.
you want. So, and I've also heard it from some people saying that for you to get what you want, for you to get better response, no matter what you use as an input that you need to like maybe restructure your prompt to give it to it for the second time to get a better response. And I've also had such experience. So I'm asking, why does it happen that way? I also want to know if a lot of people are having such experience too.
Okay, so I was trying to be sure I clearly understood you. So what you're saying that you give it a prompt, it gives you a response, and that response doesn't really match what you want. You modified your prompt a bit and give it the modified
Mm.
prompt, and then you now get a better response. If you modify the prompt
Yes,
even further, you get an even better response. Is
yes,
that what
yes,
you're saying?
exactly.
Essentially,
Yes, because
what you're doing
it's
is you are iteratively refining the prompt. So it's not the LLM's fault. It is answering you based on the prompt you gave it. So as you refine your prompt, as you give it a better prompt, you tend to get better response.
okay.
So
So
if you
what
give it
about
a good
situations?
prompt, if you give it a good prompt ab initio, you're likely to get a good response from the beginning.
Okay, but sometimes it tends to write off points. Let me just call it off points. And when I'm like saying, what are you writing? You already know a lot about me. Please, I said you should. Then I'll write the same prompt again. It will now say, oh, sorry. And at this second time, it will write exactly what it should write. So why is it happening like that? Sometimes is this sleeping, a lost
If
memory,
it's
he was
forgetting,
not prepared
then
or something like
that's a
that.
context issue. If it's forgetting
Okay.
some prior information from your conversation, that's a context issue. Remember, one of the settings we talked about was the context window. So if the context window is small, it can't remember much. If the context window is large, it can remember a lot. But it also depends on the LLM too. All LLMs are not born equal.
Okay.
So like I mentioned, an LLM is not magic. It has capabilities. It still has its limitations. So you need to understand the capabilities and limitations of the LLM you're working with. And you also need to provide it with prompts that will give you the best result from that LLM.
Okay.
All
Thank
right.
you.
So you're welcome. Someone says garbage in, garbage out. Yeah, LLM prompting techniques and pitfalls. I think they should be the next. Yeah. So there are some techniques that are used in prompting and some of the pitfalls in prompting. So the techniques include instruction prompting. Instruction prompting is where you just give it an instruction, right? What is the capital of Germany? Or you tell it no. It's write write me a three stanza poem, for example. That's an instruction. So it's usually used when for tasks that require just maybe one step or simple tasks that doesn't require multi-step approach or multi-step reasoning. That's where you use instruction prompting. That's where it works best. There's role prompting, where you assign a role to the LLM. Like you could tell it that you are an expert physicist, you are a senior software developer, you are this, you are that. You're trying to what's the term? You're trying to give it a particular persona that could be a way of getting it to give you more relevant responses. Role prompting. You assign it a role, you give it a given persona. So after you've provided with the persona, you now go to ask your question. So it's now playing the role. Maybe if you tell it that you are an astute lawyer and you want to ask it a question in law, it potentially enable you to get the more relevant responses from the LLM. You shouldn't trust legal opinions from LLMs anyway. You should take it with a pinch of salt and you should verify, like I think Adobe mentioned earlier. There's zero shot, one shot, and few shot prompting. Zero shot prompting is you just ask it what you want to ask. One shot prompting is that you provide an example of the output or an example of how it should solve that problem or how it should carry out that task. One example. Few shot is you provide it with a few examples. It could be a 3-shot, in which case you provide 3 examples, a 10-shot, in which case you provide 10 examples. But really, it will work up to a point. So you need to, depending on your particular use case, you may need to experiment to get what works best for that use case. There's chain of thought prompting. Chain of thought prompting is where you ask it to follow a step-by-step approach in solving the problem. For problems that require multi-step reasoning, step-by-step reasoning, chain of thought prompting is helpful. For something like, if you ask it, what is the sum of 2 and 3? 2 plus 3 is a straightforward thing, right? But when you want to ask it to find the integral of this, and this, if it's not a simple integral, if it's a complex function, then that is not, it is something that to solve it, you need to follow a process. And that's where chain of thought prompting becomes useful. There's context grounding, where you provide it with some context. If, for example, you could, like somebody mentioned researching, right? You want to write an article or you want to write something and you have this corpus, this set of articles that are related to that thing you're trying to write. The answer is contained in those things. You provide it with those as context. And so it retrieves the answer, it scans through those articles you provided and pulls the answer from there. That is context grounding. Context grounding must not be plenty articles. It can just be a simple paragraph that you provide. It can just be one sentence, but you're providing with a context where that is very relevant to the task you're giving it. That is context grounding. So you could provide this paragraph, say, based on this paragraph, do so and do so and do so. That's context grounding prompting. And then there's prompt chaining. In prompt chaining, you're essentially decomposing, it's not just about a step-by-step reasoning like we have in chain of thought prompting. Yeah, I need to mention that chain of thoughts actually describes how it happens. A chain of thoughts, step-by-step reasoning. You reason from one step to the other. So you chain the thoughts. That's where that chain of thoughts name came from. But in prompt chaining, if a task can be broken into different subtasks, so you can break it up and have the LLM solve each subtask independently, and then where the input to the next subtask depends on the output of the previous subtask. In that case, you use prompt chaining. This prompt for solving this subtask, and then its output becomes input to the next subtask, which has its own prompt. You chain the prompts from one to another to another. That is prompt chaining. common pitfalls of in LLM prompting. If your prompt is vague, the prompt vaguely specifies or underspecifies your task, you're not likely to get a satisfactory response from the LLM. If you remember when we talked about characteristics of a good prompt, we said it has to clearly specify the objective. The intent has to be specified clearly, as well as specifying the scope. So if you specify the task vaguely or you underspecify it, that's a pitfall. Missing context or constraints. If you do not provide full context, if you don't provide adequate context, or you do not completely specify the constraints, that will reflect on the LLM's output. You may likely not get a good quality output from the LLM. If you ask the LLM, if your prompt asks multiple unrelated questions at once, that could be confusing to the LLM, even for a human being. When somebody just asks you questions unrelated here and there, the switching of context is not so good for something that requires reasoning. So if your prompt is asking multiple unrelated questions at once, you may not get good response from the LLM. Another common pitfall is expecting one-step answer for multi-step problems. And that's why prompt chaining is good. So if it's a multi-step, or as the case may be, chain of thought, depending on the specific task. If it's a multi-step problem, you should not, if you ask for one-step answer, the LLM may tend to hallucinate. But if you ask it to work in steps, providing intermediate responses, and it works, the likelihood of getting a good response is higher. Of course, if an intermediate step, if the LLM, for example, hallucinates in an intermediate step, the steps that depend on that step are most likely not going to be correct. But then, depending on how you designed your agent, if it's an agentic system, it may be able to go back and correct that wrong step and continue working from there. Any questions so far? Okay, so move ahead. So now here is for discussion. I have this prompt here, write about climate change. I would like us to critique this prompt. And if possible, if it's necessary, let's refine it. Write about climate change. That's a prompt to an LLM. Is there anything wrong with that prompt? Yeah, Adobe, go ahead, please.
Yes, I think it's too broad. There's no focus area, and it doesn't specify the purpose, like the reason for asking the question, whether it's writing an essay or a report or something like that. And yeah, I think if it's tries to specify some things, then the LLM will find it a bit easier to respond to the question, because this particular one will lead to so many things and may not be exactly what the person will want to see. Yeah, so for me, I think it should be something like maybe trying to even include the word count or something like that, trying to limit it to some certain level. For example, it can be to write a report explaining the causes and effects of climate change, and then suggest solutions that can help maybe specify some countries like Africa to adopt and use recent what is it called, climate change. Just limit it as much as possible. That's what I'm trying to say. The word count, they like whether it's speech or reports, maybe country specific and all that. Yeah.
Okay, that's good. Anyone else? Okay, Nancy, go ahead.
All right, thank you very much. From the prompt, write about climate change. Firstly, is the prompt is very vague. It will give you different things from that prompt, but you can make it more specific, because I've come to understand that the better your goal is how you prompt them. So you have to make your prompt very specific because of how LLMs are designed. So I think if you want to give a prompt like this, firstly, you have to say, write about climate change, make it specific, maybe to a particular region, tell it an examples you want it to take, then tell it the standpoint you need it to write from. Is it writing from based on maybe someone who is an expert in the field, writing as a student, then also from what perspective you want you to write from. So if you can give it this prompt, I think you'll get better feedback from it. Thank you very much.
Okay, that's a very good one, Nancy. Trust you, your hand was raised. You want to speak?
Yeah, I think they've mentioned it already. So I can actually add that we can also, with these prompts, we can proceed it with a role prompting. You are a climate somebody, and so you are somebody that is very, very experienced in predicting climatic conditions. So you're a climatic professor or something. So, and then we can also put in some instruction that I want you to explain like somebody that is 12, because in a way, you will be able to simplify the explanation. So that will not make the answer not vague, and it will be very easy to understand.
Okay, that's good. Adobe, your hand was raised after Adobe, David.
Yes, on another note, what if someone said, okay, let's say I don't know anything about climate change, I heard it and I want to learn about it. This prompt can be explain climate change to me as a layman. So how about that? Because it's still general, it didn't specify anywhere. So how about using it that way? Because I know that someone can still use these exact prompts, like write about climate change, especially when you don't know anything about it. So what would you say about that in such condition?
Okay, now you're asking for refinement. I want us to critique it first before we talk about the refinement. David, go ahead.
Okay, thank you very much, sir. Okay, just like my colleagues have said, that statement there, it's very broad. It lacks specificity. There's no clear direction. And let's say maybe like to improve the prompt or refine it, maybe it would better put to say, write about the impact of climate change on rural communities in Nigeria, and something like that. That would be more specific. Yes, so that's what I have to say. Thank you.
Okay, Olarewaju, go ahead.
Yes, sir.
Sorry,
There's how to say.
a moment, sir, please. It's already 10 p.m. Do I have your permission for us to extend by maybe let's say 20 more minutes or thereabouts?
Yes, sir.
Okay. I just want to have more people respond. Okay, so let's go ahead then. More people have agreed. Olarewaju, go ahead. Olarewaju, go ahead with your.
Okay, sir. Recently, because I know that I need to, maybe because getting the best prompt might be difficult. Recently, I've been asking LLM to generate a prompt for me. I'll now fine tune it. So in this case, I may tell it, I want to write as a so and so person, generate the best prompt for me for this purpose. It will now come with a large whatever. I will now go through it one by one and then fine tune it and then send it back. It's not giving me the right answer. So as not to stress my head.
Yeah, that's it. That way you are actually using like sort of prompt chaining, right? Where the first step is to generate the prompt itself. And that's a smart use of the LLM. Okay, so I think we all agree that there are some issues with this prompt and that it should be refined, right? If you agree, give a thumbs up. Okay. Here we have a number of people agreeing. Okay. So let's try to refine it. I'll go back to the yeah, the characteristics of good prompts. So who wants to have a first go at trying to refine that prompt, bearing these characteristics in mind? You must not have all these in the same prompt. It depends on how how complex the task is. Some tasks you may be able to achieve without all this. For example, that are task of 1 plus 2, even though inherently LLMs are not so good at calculation that it's better to use a tool for calculation. But I mean, if you ask like, what is the capital of Germany? That's a simple, you don't need to start doing plenty, writing a lengthy prompt just for that, right? So who wants to have a first go at trying to refine this prompt? Adobe?
Okay. This one is kind of related to me. It goes this way. Write an academic style. Can you hear me?
Yes, clear, loud and clear.
Okay. Write an academic style overview of role of AI in combating climate change, suitable for master's level audience.
That's it. Now, let's look at the objectives. Have a clear objective and scope. Have you covered that?
Yes, I think I did.
Okay. Provide sufficient context and data. Have you covered that?
Yes.
Outline a structured request. Have you covered that?
Yes, I think I gave example, master's level audience.
Include output format constraints. Have you covered that?
Yes, academic style. I didn't put the word kind.
Academic style does not specify output format. Academic style is maybe more about providing context. Do you want it to be written? Academic style can be a lot. Now, scope. Your scope is a bit not so good. How many was the word length? How many paragraphs? Or you need to specify the scope, otherwise it can write 10 different books for you. It can just write one sentence. Yes, context sufficient or not.
More of what counts.
Yeah, it's arguable.
Yeah.
Whether context is sufficient or not, but you don't really need to provide so much context. Structured requests, you don't need to put so many things there, but output format, I'm sure it was not clearly specified. So you need to be clear, you need to be specific to get the best response of the LLM. Trust, you have raised your hand. You want to have a go?
Okay. So I think let me just try. You are a professor in meteorology and climate something that I'm giving the LLM a role. So about somebody that is vast in the field. Tell me about climate change in Africa. Then I can now say that include your sources from these documents, from a particular document that maybe from some established papers that have been approved and that have been peer reviewed in public journals. Then I can now say that you should write it in probably 500 words. And in the words, it should contain examples and pictures and to make the thing clearer. Then I can also include that it should make it simple enough that a 12-year-old will understand. So that's a prompt that's like cover the whole bullet points in the slide.
Okay, that's fine. I must say here that prompting is really an art, right? It's really an art. It's something that you need to iterate on until you get, excuse me, you need to iterate on it until you get what works for in a particular context. So it's not really something that this is pass, this is fail. The LLM you're using matters. The particular task matters. So it's something you need to try, iterate on, and so on. I think Adobe was the one that was asking a question why you need to ask it and ask it again. That continual refinement. But if you're able to, verify that for this particular type of task or this LLM, this is the pattern that works, then you go ahead using that until maybe you have a different LLM or another task. But they are just basic, how would I say, rules of the thumb, if I may use that are basic. You need to be clear your objective and scope. You need to provide adequate context. You need to structure your prompt as much as possible. LLM likes steps, it likes lists, right? You also need to, as much as possible, specify your output format. Before this will be your assignment. Let me give you the assignment, and then I would like us to try something before we go. But before that, here's the assignment. You are to create and test 3 progressively refined prompts for a task. I will also send this in the I wanted to say Slack, in the Discord channel. You have to create and test 3 progressively refined prompts for a task relevant to your domain. Now, the task relevant to your domain in this case will be one of those 3 challenges that you provided in the last task. Remember, the last assignment was be ready to defend this in the class. So in one of those, choose one of those 3 you mentioned, any of them out of those 3, and iteratively refine a prompt. You put a task. Well, it may not be the entire task. It can just be an aspect of it, right? Because some of those things are large. Just pick an aspect of it. Write a prompt that for that aspect of it, for that step, and for that step of the what you have written, and iteratively refine it up to 3 refinements. For each of the refinements, you state what the objective is. You show the prompt and the corresponding model output. So you're going to run this. You're going to use Olama. You're supposed to have installed Olama. So for each one, you show the prompt and the corresponding model output. So I'll be expecting to see the model output improving as you are refining the prompt. And then you also reflect on how the refinement you've done, how you're changing the wording of the prompt has changed the output. I'm going to create a thread, the thread where I'll post this assignment in the Discord channel. Your response should be, your submission should be posted as a response in that thread. You just respond to that, right? Now, what I want us to
Sorry, I can't hear anything. Is it from my own end? Okay, it's not only me.
Please, can somebody explain this assignment for me? I don't understand, please.
Hi, Chloe. He said he's going to share the assignments, I think, inside Discord and create a thread. I think the explanation to the assignment will be given there. Meanwhile, just to create the prompt that is progressive, like in 3 stages, but it has to depend on the first one, then the second one, then the last one. But he said that you must use any of the terms you used in the previous assignments, like your personal and work experience. Okay, he's back.
Yeah, sorry, I think my network went off. I had to switch to another network still. Yeah, you were explaining that correctly.
Welcome, sir.
Thank you. So the last thing I know, I was asking who had not installed Olama yet, and Chukudi raised his hand. No, I didn't see any other hand, so I'm assuming of everybody here, he's the only one who has not done that. Okay, Nancy, you have not installed Olama.
No,
Okay, please, you
I
need.
did not raise up my hand because I've not installed it.
Okay. So go ahead. You will have a question.
It was basically on how to understand the assignments which Adobe was explaining before you joined.
Okay,
Yes, that was what I was explaining to him.
okay. So Nancy, was it because you hadn't installed Olama that you raised your hand, or you want to say something?
Yes, I haven't installed it, sir.
Okay, Femi, you have not installed it too?
Sorry, I've
Okay.
installed it, but I think the next stage that I was talking about group, maybe getting an API. I don't understand that, please. So that's where I stopped.
But you have installed Olama, right?
Yeah, I've installed Ulama.
Okay. The API key is Grok API key. I provided the link. For that. Go ahead.
All right. So are we to get the API key before installing the remaining 3? That's LangChain, OpenAI, then LangChain, Brook, then
You don't have to install LangChain OpenAI or LangChain Anthropic. I just mentioned that LangChain has integrations with OpenAI and Anthropic. You don't have to install those. You just need to install LangChain Olama after you have installed Olama, and then you install LangChain Grok, because we'll be using Olama and Grok. But
All
you
right,
can
sir.
install LangChain Grok even without getting the API key, just that you will not be able to make any calls to the Grok API without the API key. You can just go Google Grok,
Yeah.
right? Grok API key, and you'll find the link to get a Grok API key. Keep your API key secure.
All right.
Don't share it with anyone.
Thank you, sir.
Can you hear me?
Yes, I can hear you.
Okay. I guess I just have to round off from my phone because the network is just fluctuating on my laptop. So I was saying that when you, after installing Olama, for you to be able to run local models on Olama, you need to pull the models. You need to pull model. So Olama, there's the how do I typically you could just go to open Olama, you see the UI, you can just ask a question. So I would like us to open Olama now and ask. These are prompts that we said was not fine. Write about climate change. Let's see what it tells us. Can we try that?
Yes, sir.
I'm
In our
trying it myself
environment.
too. I just hope that my network will allow me to do this. My two main networks are down. If you get a response on your end, could you post that response in the chat?
Are we putting just right about climate change? Hello?
If you've been able to start this, if you've been able to send the prompts yet, just react with an emoji. Can be a thumbs up or whatever.
Please, I have a question. Hello?
Okay.
Please, can you hear me, sir? Hello,
Write
can you hear me,
just
sir?
just write the prompt and send.
Apart from David, has anyone else been able to
Sir, please, I have a
fire the
question,
prompt
sir.
to the LLM?
Can you hear me, sir?
Mine
Hello,
is
sir.
still generating a response. Although I'm not using a locally run model.
Hello?
I'm using the turbo, which runs a model in
I have
the
a
cloud.
question, sir.
Okay, so you're trying to pull. Do you have the option for the turbo? Are you running from the terminal or from the Olama UI?
It's from the software.
David?
From the Olama app UI.
I can.
I sent a message. I dropped a message.
Okay, from the
16 gig.
Do you have GPT? Do you have Olama Turbo available? Is it showing there? The Turbo. Because if you have the Turbo, you can run models that are in the cloud without pulling any model locally. Okay, anyway, one thing is for you to really use Olama locally, you need to pull the models. Okay, you don't have the Turbo. That's fine. You need to pull the models. And how you can pull the model, I wanted to, is just a moment. Let me exit this first. If you go to your terminal and you type Olama, if you open a terminal, CMD, whichever terminal you use, and type Olama, it will show you the different commands that you can run. One command is pull. Pull allows you to pull a model. You can pull multiple models. And run allows you to run that model. List will list the models that have been pulled to your system, which are the models you can run. So if you run Olama list, it should list the models. Now, before you pull a model, you need to verify that your system resources can run that particular model. And so I'll recommend these models for us. You can pull more if your system resources can allow it. Oh, I'm not even sure. My system may be more than, but let's try. I think we should all be able to run that if we have up to 8 gig of memory, preferably 16 gig. You can do Llama 3.23. Okay, I'll send these models that I recommend we pull. You can pull any model depending on your system, but before you pull the model, try to check the system requirement for that model on the Olama website and see whether you can actually run it based on your system configuration. So I'm going to send one, the assignment, two, models I recommend that we pull, and then you can pull any other model you want if your system can carry it. The other thing I would like us to do when we have pulled the model is to try to run this our prompt right about climate change. See what, try to run it with different models, see what they respond. That gives you an idea of how good or in quotes bad that prompt is. Ladies and gentlemen, I think we need to round off because it's about 27 minutes past 10. Does anybody have any further questions for me today? If not, then let's call it a night. If you have a question, just unmute yourself and ask. If not, let's just call it a night. Okay, I guess there's no question. So, ladies and gentlemen, thank you for listening and thank you for contributing actively. Even though really only a few of us contributed actively, a lot of us are just silent listeners. I would like if we all contribute, if we all speak up, if it as interactive as possible. That way we all share ideas, we all benefit from the training. Thank you and good night.
Very good night, sir. Thank you, sir.
Thank you and good night. Good night, everyone.